This tutorial is going to help you out with this whole force diagrams thing. So follow along, all right? Before I actually start showing you how to do force diagrams, I'm going to introduce you to 6 different forces. Really 5. I'm going to introduce you to 5. Okay, so the first force I'm going to talk about is known as applied force. Okay, applied force is basically any force that is applied on an object by an object. So basically, let's say I got this person. This person is pushing something, like a box. He's pushing a box. All right. That box, let me go ahead and it's a push. It can be a push or a pull. Anytime when you are applying a force to something. So let me write that down. So this is in your notes. You might want to check your notes. And I also, if you go to the tab that says notes and you click on Newton's first law, it will, you should get these notes that pop up. But anyhow, basically applied force is a push or a pull. Okay, so if I was to actually draw, some arrows to show what was actually happening here, then let's say this person was pushing this box. Then that means he was applying force to the box. Okay, there you go. Then we're going to move on to the next one. The next one is normal force. Normal force is basically the force that keeps an object from falling through something else. So let's say I have a table, okay, and I have a book. I'm going to just say that my book is sideways. There you go. This is my book. Anyhow, normal force is actually the upward pushing. It goes against gravity. So it's keeping this book from falling down through the table, okay? So as you see what I have written, it says it is a support that keeps an object from falling through another object. So you could be sitting in a chair. Oops, that's an ugly chair. So you could be sitting in a chair, okay? And here you are, there's your legs, and your arms are folded, I guess. Anyhow, so you're sitting in a chair, and what's keeping you from falling through? Normal force is pushing up against you. Gravity is pulling you down, but normal force is what keeps you from falling through the chair. Isn't that exciting? Okay, next. Then we have friction force. Friction force is not necessarily something that you would probably think of as friction force. Basically what it is when an object tries to move across another surface. So anytime you walk or slide or jump or hop or skip or whatever you do, anytime something is moved across another surface, for instance, you're walking on the carpet, your feet are going across the surface. If you are going down a slide, your butt is going down plastic, or metal. I don't think they have metal slides anymore. Anyhow, either way, an object is moving across another object, then you are going to get friction force, okay? This is basically going to always be working against gravity, all right? This is, again, the definition. This is a force given when an object moves across another object, okay? So let's say here's my person, and they are walking forward. There's their forward walking hands, okay? They're walking forward across the grass, all right? So friction is always going to go, so if they're walking this direction, friction is always going to be going the opposite direction that they're walking, because friction wants to slow you down. So this is the friction force. This is the friction. It always wants to slow down the direction that you're going. Friction is what causes you to stop. If it wasn't for friction, you would just continue to walk or even slide, and then you would just never stop until you bumped into something. Okay, so now let's go on to the next one. Then there's gravity. We're all very familiar with gravity. Gravity is basically the force that pulls any object to the center of the earth. All right. If you live on planet Earth, you will experience gravity in all aspects. All right. So let's say I have, this is let's see if you can guess. Woohoo. Can you guess what it is? All right. Yeah. Okay. This is a body. And what do you think they're doing? Yes, they're jumping. Extremely happy. Jump. Okay, so they're jumping up. This is the direction that they're moving, up. All right, but which direction do you think gravity is going to be pulling on? Down. because it's always going to try to get you to go downward, back to the center of the earth. So you might go up for a little while, but you're going to come back down. You know, there's that saying, what goes up must come down. Gravity is what pulls you down. And if it wasn't for gravity, you would jump up and never come down. Okay? That would actually suck. Imagine what life would be like if there was no gravity. It wouldn't actually be as cool as you think. Okay, and then there's air resistance. Okay, so then there is air resistance. And basically air resistance is when air pushes on an object as an object tries to move through air. So if you, again, live on planet Earth and you try to move through air, any object that moves is moving through air because on Earth you experience air. All right, so here is an example. I have a bird. Please don't make fun of my bird. And my bird is flying through the air with the greatest of ease, okay? And he's moving forward, all right? So as the bird is moving forward, you have air resistance that want to move in the opposite direction of which way the bird is going. So the bird would not be able to fly as fast as it actually could because air resistance is always going the opposite direction. So as you see, he's moving this way. Excuse me. He's moving that way, but the air resistance is moving this way, okay? And then I have another example. Say you are a person and you throw a ball up in the air. You know, you're going to experience air resistance. You know, as the ball is going up, you're going to experience air resistance going the opposite way. So the ball is going up, but air resistance is going this way, okay? And then when the ball falls down, you're going to experience air resistance going the opposite direction. So now the ball is coming down, but air resistance is pushing up. Basically, air resistance is like the hater to whatever is happening. So if you're trying to go forward, air resistance is going to push you the opposite way. Okay? That's basically how you can remember that. You like my saying, hater. All right. And then I did say there was five. I was really going to talk about 6 or 5. I'm just going to mention the next one. I'm not really going to go over it significantly. This is tension force. And basically tension force is any time you've got like a rope or a string or, you know, a wire pulling on you. So like if I, you know, have this person right here and they are being pulled. Let's say there's a rope around their arms and they're being pulled in opposite directions. Then this would be an example of tension force because tension requires for there to be a rope or a string or a wire or something of that sort. Okay, so that is your review on the types of forces. All right, stay with me, and now we're going to go through actual force diagrams. Yay. So my first example is a person jumping on a trampoline. Hopefully I spelled trampoline right. Okay, now the nice thing about force diagrams is you don't actually have to spend the time drawing these elaborate, beautiful pictures like I did before. No, you don't have to do that. Instead, you're going to draw a box, you know, or a dot, you know, whatever you feel like drawing, but something small, and that is going to represent the object, a person jumping on a trampoline. All right, so now you have to figure out what of all the 5, 4, or even 6 forces that I went over. You've got applied, okay, you have normal force, you have friction, you have gravity, and you have air resistance. And, you know, I guess for the heck of it, we'll just throw in tension. All right, what forces do you think is happening here, and which directions are they going? So first of all, person is on a trampoline. If they are jumping, is that an applied force, a normal force, friction, gravity, air? You know, a person jumping is an actual force that they are applying. So they are actually applying a force in the upward direction. So I'm going to draw an arrow going up, and I'm going to label that applied. Okay? Now, they're going to come down. What goes up must come down, which means gravity is also, you know, a part of this whole deal. So you've got, oh my gosh, what happened here? You have gravity. Gravity is going down. Okay, and now being that this person we're going to assume is on the planet Earth, is there or is there not air in this, you know, atmosphere? So if they are going through air, then, you know, we're going to go ahead and add air resistance. And now here's the tricky part. The direction that you are applying force in happens to be going up. Air resistance, remember I said, is like the hater to whatever you're trying to do. If you're trying to go forward, it's going to go backwards. So if you're going up, then air resistance is going to go down. Okay? So here is my air resistance. Alright. We could stop there. I mean, there's other ways we could incorporate normal force and friction, but I'm going to stop there. That's all that's necessary. I really need to see, the ones that I really need to see are applied force and gravity, for sure. Okay? Here's an example 2. So it says a car is driving forward down the road. Okay? So here's my dot that represents the car. Okay? And remember, we have applied force, we have normal, we have friction, gravity, and we have air resistance. Those are the 5 that we're really concerned about. Okay? So, first thing, the car is driving forward. There is obviously a applied force going on. Where do you think this applied force can be coming from in a car? What is it that causes the car to move forward? It would be the engine. Okay, so a car is driving forward, so that would be an applied force. Okay, and what do you think is slowing the car down? The car happens to be moving on a surface, isn't it? The road. So would that not be friction? Because remember, friction is any time a car, or excuse me, an object moves across a surface. So friction is always going to go the opposite direction of applied force. Friction is also like the hater. So whichever direction you are applying force, friction is going to go the opposite way. So you have friction is going this way. Okay? That's ugly. Let me fix that. Friction. And again, 3rd time's a charm. Friction. Alright. Is your car moving through anything? So we have applied force. Is your car moving through anything by chance? Air by chance? Yes. So if your car is going forward, remember, air resistance is also going to be going against your car. And you can experience this when you're riding in a car and you put your hand out the window, you feel the wind on your hand. You feel significant air resistance. Okay, so now, is your car floating through the atmosphere or is it on the ground? Because if it's on the ground, then that means gravity is pulling you to the center of the earth. And then, did you fall through the ground? Like, are you just floating through the middle of the ground or are you on top of it? Because if you did, then that means normal force is keeping you above. Okay? The key to these whole force diagrams is knowing these. Like, you have to know these, and if you don't know them, then you need to be able to go and look through your notes until you and just kind of, process of elimination. So you look at it and say, well, am I applying force? Is there a push or a pull happening? Is this normal force? Is there something that's keeping me from falling through another object? Like in the car situation, the ground, it didn't fall through the ground, so that means normal force must be there. Is there friction? Is there force? Is an object moving across another object? Well, the car is moving across the road, so, And then gravity, am I floating off into the atmosphere or am I on the earth? If I'm on the earth, then gravity is present. And once you figure those out, then you need to know which direction your arrows are going. Is air pushing on an object? Is an object moving through air? Then air resistance is present, okay? That's basically all you do in this situation. You kind of just go through and you circle. In this situation, all 5 of them, but you have to know which direction the arrows are going to be facing, okay? So let's do example 3. So I got a book that is sitting on a table, meaning it's motionless. So here is my dot. It's not going anywhere. The dot is going to represent the book, alright? And it's sitting on a table. It's not going anywhere. It's not moving through anything. This should be very simple. So let's go ahead and, I'm writing these out, but you don't have to. You can just look in your notes. So you got applied force, you have normal force, friction, you got gravity, and you have air. Okay, and then there's tension, which I'm kind of ignoring that one. Just, we don't really need it for this class. So, applied force. Is there a push or a pull taking place? Is the book pushing or pulling on anything? No. Okay. Is the book falling through the table, or is there a force that's keeping it up? That would be normal. So, yes, we have that. So, normal is going up because it's keeping you from going down. So, that's why your arrow is going up. Is there friction? Is the book moving across the surface? No. It's not. So no friction. Is there gravity? Is gravity pulling you downward towards the center of the earth, keeping you from floating off into the atmosphere? Yes, because the book is sitting on a table. So then which direction is gravity going to go? The way it pulls you, which is down. Okay, so good for gravity. Is there air resistance? Is the book moving through air? It's not moving, so no air resistance. Alright, so let me go ahead and label these, which you should always do immediately. Normal force, gravity. That's that. Yay. Now the next one, you have a rock falling down towards Earth. Okay, so let's draw our stuff again. We got normal force, you have applied, you have friction, you have what is it? Sorry, air resistance, and you've got gravity. Okay, so here's my rock. It says a rock is falling down towards the Earth. Okay, is normal force present? Is anything keeping it from falling through something? No, normal force isn't really doing a job. If it is there, it's very little, not enough for me to want to put it. Is there an applied force? Is there anything pushing or pulling it? It doesn't say that someone threw the rock. It just says it's falling. So there would be no normal, there would be no applied. Is there friction involved by chance? Is the object moving across a surface? If you want to be technical, you could say it's moving across air. You know, you could say that. So I will draw that, and that's like bonus if you're just super awesome. All right, so we can say there is friction. Is the rock moving through air? Yes, it is. So boom, air resistance. Okay, is the object floating in the atmosphere, or is it falling, or is it going down towards the ground? It's definitely going down towards the ground. So we're going to definitely use or put an arrow for that. Now I just want to point out, notice the sizes of my arrows. Which one is the biggest one? It'd be, in this situation, gravity is the biggest one. And gravity is big because the rock is actually going down. You don't want to draw these so that they're all even, because if they are all even, then that means that this object is not moving, or it's moving at a constant speed. You want to show that this rock is moving down, because this arrow is obviously overpowering everything else. Okay? Okay, I'm going to just include these last two just because I know this is more difficult. So here you go. First one, example 5. You go down a slide. So here is my person. You're going down a slide. So to go down a slide, that means there must be gravity, right? Also, that must mean if you're not going through the slide, you're going down it, but you didn't fall through it, there must be normal force. Applied force is kind of iffy. You can put it or not. But there definitely is friction. And which direction do you think friction is going? If you're going down, friction is always going to go the opposite direction that you're going. So friction would be right here. And then you're going through air. And air is also always going to go the opposite direction you're going. So that means you have air resistance. Okay. If you were going to put applied force, then applied would go down here. Okay. And now I'm going to do example number 6. You run to the finish line. I didn't really tell you which direction you're running. So let's just pretend. Honestly, I'm going to say you're going to run to the right this way. All right. So you run. This is an applied force because you are doing it yourself. Friction is always going to be going against you because you're going across the surface. All right. So friction always goes the opposite direction of an applied force. And something else does too. Remember, air resistance also always goes the opposite direction of an applied force. If you're on the ground, that means gravity has some way, some kind of hold on you. And if you didn't fall through the ground, then that means normal force is also helping you out. Alright, and that's the way that is. That's it.